So today I'm going to be talking about the speed of sound and breaking the sound barrier and the sonic boom. So the speed of sound at sea level is 340.29 meters per second, and it is defined as the distance per unit time by a sound wave that propagates through an elastic medium. Typically, we think of air. However, the speed of sound moves slowest through gases like air, and faster through liquids, and even faster through solids. I wanted to explore this topic because in the last unit we touched on the speed of light and electromagnetic waves and stuff like that. So this video is going to touch on the speed of sound and sound waves, which are similar and interesting. So going back in history, the most accurate speed of sound was published in 1709 by Reverend William Dersham, who was the rector of Upminster. He measured the speed of sound by observing a shotgun being fired in the distance and measured from when it was fired to when he heard the sound of it being fired with a pendulum that measured to the half second. So in 1947, Chuck Yeager, an American military pilot, became the first person to break the sound barrier, meaning he traveled faster than the speed of sound, and he was the first person to ever reach a speed of that magnitude. So when a plane travels at supersonic speed, it creates a shock wave that comes with a loud thunder-like noise known as a sonic boom. Normally, sound travels in circular rings at the same speed in all directions, expanding outward expanding in its radius, as exemplified by a rock in a pond and its ripples moving out, or even a stationary home stereo. Even though we can't see the sound waves, it's occurring and expanding in radii, moving outward at the same speed. So sound then travels along a ray that is perpendicular to the concentric spheres being formed by the sound, which is similar to the equipotential lines we learned about in the electric field unit. In contrast, when a sound source is moving, like say a train, which introduces the Doppler effect, it creates rings that look like this. The bunching of waves toward the front, say of a train, is the result of a greater wave frequency. And this is the same effect that occurs when a plane speeds up and ultimately will break the sound barrier. So when the source of a sound, say a plane, travels at a speed greater than that of the sound it makes, it's called traveling at supersonic speed. Because the traveling object is at a speed greater than its sound, a plane, for example, isn't heard as it first appears. After it has passed, the sonic boom is heard. This is due to the shape of the sound waves that is formed around the plane. And due to the diagonal line, it doesn't hit the people that the plane passes until after it has passed. So the shape, which is a hyperbola that the sound makes with the ground, is what helps the scientists determine what area of the ground will be affected by the sonic boom. So I hope y'all enjoyed my short video on the speed of sound and breaking the sound barrier. Even though it was brief, I hope it was interesting and informative. So thanks for watching.